Some of you guys might be wondering about the central limit theorem and how to use its properties quite lately, and I observed that during the exam, so I would give clarity on it. And I do think that some of my lectures, like honestly, I think they were quite unclear. So I hope in this lecture we can finally set it to stone. I mean, what should we do and what should we not do? Alright, first and foremost, why do we need to do central limit theorem? Again, it's because most of the time when a researcher does his research, we don't really know what the distribution is. But the central limit theorem allows us to change this distribution into a normal distribution. But take note that this normal distribution is not just any kind of normal distribution. It is a sampling distribution of the sample means. Alright, I hope you understand what a sample mean is. From the population, we can grab many number of samples, but within those samples, it would have a sample size. Alright, so let's say that I have 5 samples that I obtained maybe by survey, or maybe by just normal questionnaire, or whatever kind of way that I gathered my samples. But within those 5 samples, I can have elements inside, alright? Elements. Like, let's say for sample 1, I would have 10 elements inside. And so that means that the sample size for sample 1 is equal to 10. Now, one of the things that we need to do in basic, again I would repeat, in basic central limit theorem is to keep the sample size of each samples to be the same. Alright, we need to make sure that we should do that. If we didn't do that, there are ways to fix, there are ways to modify how the central limit theorem works, but for our case and purposes, we'll just deal with the most simplest case, where all the sample size are all the same. So the elements inside each samples are 10. Now, what we do is we get the mean. Again, I would repeat, the mean of the elements. There are 10 of them, right? So we would get the mean of the 10 elements, and that would be our statistic. A statistic is the thing that we put into the normal distribution. Alright, so I would repeat. For the samples, for the first sample that we get from an unknown population distribution, alright, we got 10 elements. From that, maybe it could be weight or height. So we went to one city and we got 10 samples from one city, went to the second city and we got 10 samples from the other city. We went to a third city and we get 10 samples. Then for each of those 10 samples we got its mean, alright? And those means would go into our distribution, right? Each of those xi bar xi's would go in our distribution. Of course, the distribution would form a mean. It would form a scatter. Unfortunately, the scatter, the distribution that it forms is a normal distribution. So again, we call this a sampling distribution. I hope you understand why it's called sampling distribution, for the reason that it is obtained by getting samples. Sampling distribution of the sample means. So I hope you understand why it's called sample means now, because all the things that we put into this normal distributions are x bar I, not xi, not this individual data, but the mean of each sample with 10 elements. Another thing I wanted to clear out is how do we get the standard deviation? The standard deviation of the sample means. What I mean is, how do we get the standard deviation of this distribution? Alright, fortunately, it can be related to the population standard deviation over square root of n. Now, I would want to clarify what n is. Alright, I keep saying sample size, but I think in the last videos I was not really clear on it. Honestly, I think I was not clear on it. So I wanted to put this into stone. Finally, the n that we're using in here is the sample size. The sample size. So in this particular example, we have 5 samples and we have a sample size of 10. So n is equal to 10 because there's 10 elements on each of the samples. That's the reason why I told you that it's much easier if we just have a constant number of sample size, because it would affect this formula per se. And also, to be much more clear, this sigma is the standard deviation of the population distribution. Alright, so if we wanted to estimate that, we can get the standard deviation of this normal distribution. And how do we get the standard deviation? If you wanted to estimate the sigma, how do we get the standard deviation of this distribution? Well, it is the same thing that we always talk about. It is just the expected value of your statistic, and each statistic here is x bar I, right? Minus the mean of the means, right? It's the mean of the means of x by I. So it's this mean of the means is this. That is the mean of the means of xi. I hope you understand what the mean of the means is. Squared, the expectation value of this squared, and that's the variance. Make sure that you know that that's the variance, and you know how to get the standard deviation from the variance. The standard deviation is just the square root of the variance.